Okay, today I'm going to give you a brief review of Chapter 8. You are doing the summary and the review and preparing not only for your exam over Chapter 8, but you're also preparing for a midterm examination, which is coming up. And you're also preparing for the rest of your life because Chapter 8 shows up a lot in this book. In Chapter 8, you first learned about very large and very small numbers, and you learned that they could be written in scientific notation. You also learned that we are very persnickety about scientific notation form. Proper form is written like this: a times 10 to the b, where a is an integer that is at least 1 and less than 10. In other words, it can be 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay, so you could write 3 times 10 to the 4th, and that is proper scientific notation form. You would not write 30 times 10 cubed and expect to get full credit or any credit. Now, you also learned many laws. The first of the laws that you learned was called the product of two powers, and that is when you're multiplying the same bases. And when you multiply same bases, then you're simply going to add the exponent. So in this case, x to the a times x to the b equals x to the a plus b, okay? Same bases, we simply add the exponents. Now, some examples that you might run into would be like this: 3 to the 4th times 3 to the 6th equals 3 to the 4 plus 6, or 10, okay? Now, we also get that in scientific notation form. If we had 6 times 10 to the 6th times 9 times 10 to the 9th, we're going to multiply our 6 times 9, which gives us 54, and then we're going to take our bases that are the same, and because we're multiplying, we're going to add those exponents. So we're going to get 10 to the 15th. Now, if you leave your answer like that, are you correct? No, we need to put it in proper scientific notation form. Now, in this case, we're going to have to move this imaginary decimal to the left. And when we move it to the left, we're making 54 much smaller, 10 times smaller, in fact, to get 5.4. That means we're going to make the exponent 10 times larger. So we make the 54 smaller, we make the 10 to the 15 larger, and we get proper scientific notation form. The second law that we learned was called the quotient of two powers. Again, we have the same bases in a division problem this time. When we're dividing powers of the same bases, we simply subtract the numerator's power, subtract the denominator's power from the numerator's power. In other words, x to the a minus b. I'm sure I've made that much more complicated sounding than it really is. Notice they have the same base. You would get problems like this, okay? 3 to the 6th divided by 3 squared is going to be 3 to the 6 minus 2, or 3 to the 4th, okay? X to the negative 7 divided by x to the negative 9 is actually x to the negative 7 minus a negative 9. And we know that when we subtract a negative, we're really adding a positive, and so we end up with x squared. Notice the same base, we just subtract the exponents. Same base, subtract. Okay, now you also are going to have scientific notation. You're going to divide 4 divided by 5, which is 0.8 times, and then 1 minus 6. So it's going to be 10 to the negative 5. Now, that is not proper scientific notation form because we know we have to have a number to the left of the decimal. So we're going to move this decimal to the right and make that 0.8 8. And we've made the 0.8 10 times larger, so we're going to make this exponent 10 times smaller to compensate. And we're going to make it negative 6. The third thing that we learned was the power of a power. And that's if we have base with an exponent raised to another exponent. That's when we multiply the exponent. So x to the a raised to the b is x to the a times b. If you see it, it would be something like this. X to the 5 raised to the 2 is simply x to the 10th. And you'll see many, many more examples of that as you do your homework. Then we learned about 2 rules. And don't worry, we still have 2 more laws to learn or remember. Our 2 rules were that if you have anything to the 0 power except for 0, it equals 1. And we also learned the definition of a negative exponent. So if you had x to a negative exponent, it's going to be the same thing as 1 over x to that same exponent, but no longer negative. Okay, so if you had 12 to the 0, it equals 1. 5 to the negative 4 is going to be 1 over 5 to the 4th. And sometimes you'll need to actually figure out what 5 to the 4th is. But basically, negative exponent, and if it's up top, as I would say, you're going to move it downstairs and it becomes positive. If you had a negative exponent, let's say you had 1 over 3 to the negative 2 and it was downstairs, then to make it positive, you would just simply move it upstairs. Okay, your book will help lead you through some problems like that. The 4th law that we learned was the power of a product. And that's if we have 2 different bases inside parentheses raised to a power, then that power applies to both of these bases. And now this rule means we have different bases, but we have the same exponent. And your book is going to make you go from here to here as well as from this way to that way. So you really have to be careful to make sure you understand what is being asked of you. If you had 7y raised to the negative 1, for instance, that negative 1 applies to both of these, okay? And then if your book asked you to represent that without any negative exponents, sorry about that, you're going to say that it equals 1 over 7y, okay? And you can put the little ones there if you want to, not necessary, of course. Now, if you have a scientific notation raised to a power, that means that that 4 also applies to the 3. So it's really 3 to the 4th times 10 to the 2 times 4, or the 8th. Okay, now of course you can't just leave it in this form because it's not proper scientific notation. You'd have to say 3 to the 4th, which equals, by the way, 81, okay, times 10 to the 8th. And again, it is not proper scientific notation form. You would have to move that imaginary decimal to the left, get 8.1. Now, because we've made 81 10 times smaller, we're going to have to make this exponent bigger. So we end up with 8.1 times 10 to the 9th. The last rule that we learned was the power of a quotient. This is when you have a division problem with exponents and you have different bases. Okay, if you had this situation where you have x over y is raised to the a power, it's the same thing as x to the a divided by y to the a. And again, your book's going to expect you to go from here to here as well as from here to here. If you had this problem, you would simply say you had x to the 4th over y to the 2 times 4, or y to the 8th. Now you can see you're applying 2 different laws here. Okay, in this problem, you've got different bases, same exponent, okay? And so when you have this situation, you're going to just take the 12 and divide it by the 3 and end up with 4 to the 7th. So the exponents that are the same, the exponent will stay the same and you'll divide the bases, okay? Make sure you notice the difference between laws 4 and 5 and laws 1 and 2, okay? Because you're in 1, you don't have the same bases. Not literally 1, 4 and 5. Okay, and the last thing that your chapter covered, we learned in just the last lesson, so I'm not going to do a lot of reminding, but that is the exponential function. That's if you have y is equal to a times b to the x, and you'll fill out a table basically. There's no slope-intercept form or any magical charm. You'll just go ahead and use the tools that you have learned. Now, as you finish this chapter, you do know what you need to know about exponents, but you really need to think to apply those tools correctly. So, happy thinking!